Class we have seen regarding the Z transform, right? Uh, we are applying the Z transform to a linear differential equation. Is that uh, the linear differential equation gets transformed into a algebraic equation, right? Thereby simplifying the analysis of discrete time system will be very easy, right? That's what we are going for the Z transform, just like what we have the other transform like Laplace transform. Just we are converting one domain to the other domain, right? And we have defined the Z transform, that is what is that? X of z is equal to summation of n is equal to minus infinity plus infinity x of n z to the power of minus n, right? That's what we have defined the Z transform. And also we have defined the ROC, region of convergence. What is that region of convergence? The range of values of a complex variable z for which the Z transform converges, right, is called the region of convergence. That's also we have defined. And we have seen some of the sequences, that is a right-sided sequence, or you can also call as the what is that, a causal sequence. And we have seen the left-sided sequence, anti-causal sequence, and we have also seen the double sided sequence, right? And with one example also we have seen that for right-handed sequence is z is ROC, that is z greater than 0. And for the left-sided sequence, the ROC, that is z is less than infinity. And for z what is that, for double-sided sequence the ROC is uh, entire, right, entire z plane, except at z is equal to 0 and z is equal to infinity. Right, that's what we have seen with respect to the Z transform. And also we have seen some of the problems, right, and it will be very easy problems based on the Z transform. Just you need to apply the formula, that is x of z is equal to summation of minus infinity plus infinity x of n z to the power of minus n. Definitely you can easily get the answer for the Z transform. Okay, please refer the previous notes also, whatever I have sent you, right? Now let us discuss the inverse Z transform, and please see all the properties of ROC also. Okay, was also important. Properties of ROC also very important. In that you need to concentrate on the initial value theorem and final value theorem. Okay, those things are very important things, right? Let us see the inverse Z transform by one method. You can solve the inverse Z transform by partial fraction method or a long division method, right? Let us try one problem with the partial fraction method. Okay, find the inverse Z transform by partial fraction method. Okay, right, very first problem, let us see that find the inverse Z transform of a sequence x of z is equal to z divided by 3z square minus 4z plus 1 for different values of ROC. Okay, that is when z is greater than 1, or when z is less than 1 by 3, or z is between 1 by 3 and 1, right? When you're writing greater than 1, z greater than 1 indicates the poles. Okay, when you're plotting the ROC, that is x-axis what you are taking is real z, and y-axis is imaginary z. When you are having the z ROC, that is z greater than 1, it indicates the ROC is outside that pole what you are plotting in the graph. Okay, that is pole you are plotting with this multiplication sign, isn't it? So out of arrows is exterior to the one. It indicates the what kind of sequence. Right handed sequence or positive a time sequence, what we are calling it, right? Positive time sequence, or right handed sequence, or you can call it also as a causal sequence. Okay, very first problem, let us try with the causal sequence, that is ROC Z greater than 1. All right. For that, what you have to do is the partial fraction method. We have the formula. What is the equation they have given? X of z is equal to z divided by 3z square minus 4z plus 1. Right. Write it as take that z towards left hand side. It goes to the denominator. It becomes x of z by z is equal to 1 divided by 3z square minus 4z plus 1. Right. And when you are taking 3 as a common, it becomes 1 divided by uh, that is 1 divided by 3 is outside. If you take, it becomes z square minus 4 by 3z plus 1 by 3, right? And if you further write it, you can get it as, if you take 3 outside, it becomes z minus 1 by 3 into z minus 1. You have to make in this kind of form in the beginning itself, right? Very easy. That is 3 into z minus 1 by 3 into z minus 1. Easily you can make it, right? That is x of z by z. You can write it as a divided by z minus 1 by 3 plus b divided by z minus 1. Doesn't mean that you can write a, b. You can take any value, x, y, z, whatever value variable you can comfortable, you can assign it. And you need to find the value of a and b in the beginning itself, right? To find the value of a, what you can write, a is equal to, by different method you can find as your wish, and you can just multiply, cross multiply, and what is that, substitute the value of z is equal to 1 by 3 and z is equal to 1. You can get the value of a and b easily. The other method you can follow is, here you can see a is equal to z minus 1 by 3, whatever the denominator, whatever you are finding, write it, that is z minus 1 by 3 multiply into 1 divided by 3 into z minus 1 by 3 into z minus 1. Right? If you are finding the value of b, write the denominator is b is equal to z minus 1 multiply into 1 divided by 3 into z minus 1 by 3 into z minus 1. By taking z is equal to 1 by 3, you can get the value of a is equal to minus 1 by 2. By taking b is equal to, however, z is equal to 1, you can get the value of b is equal to 1 by 2. Hence you can write the x of z by z is equal to minus 1 by 2 is the value of a divided by z minus 1 by 3 plus b value is 1 by 2 divided by z minus 1, right? Then you can take z to the other side, that right hand side. It becomes, that is x of z is equal to, as it is, minus 1 by 2 z divided by z minus 1 by 3 plus 1 by 2 z divided by z minus 1. When you are taking the inverse z transform, you should remember some standard formula. What was that? It is the z transform of a to the power of u of n is equal to z divided by z minus a. Okay, for z greater than a, and other formula also, that is, what is that, different formula, n into a to the power of n minus 1 u of n, its z transform is what, z divided by z minus a whole square. The different standard forms whatever we are having, you should know those things, right? Here, that is z divided by z minus 1 by 3, right? Here a value is how much, 1 by 3. You can write a to the power of n u of n, nothing but 1 by 3 to the power of n u of n, right? And one of the other is the, what was the other things, it is 1 to the power of n and u of n, and those are the constant terms, of minus 1 by 2 and another is 1 by 2 is a constant, right? You can see the poles here. What are the poles? How to find the folds? By making the denominator is equal to 0, right? You can find the folds. How to find the zeros? By making numerator is equal to 0, right? If you make denominator is equal to 0, you can get the poles value is equal to how much? That is z minus 1 by 3 is equal to 0, that is z is equal to 1 by 3. Z minus 1 is equal to 0, z is equal to 1. You can have the different poles and you can plot the graph, right, of ROC. That is real z is x-axis, y-axis is the imaginary z. You can have the different poles, right? Here what has happened, that here ROC is the outside the circle, hence it will be the positive sided sequence, or you can call it as a causal sequence. If you take z is less than 1 by 3, what happens? It is a negative sided sequence or anti-causal sequence, right? So everything is same. Everything is same. You can get the value of z is equal to 1 by 3 and z is equal to 1. The only thing is, at the answer you have to what is that? You have to, sorry, what is the value of z? Everything is same. The poles are same, zeros are same. That is z is equal to 1 by 3 poles and z is equal to, everything is same. The only thing is, since it is anti-causal sequence, we need to concentrate on the standard form what we have. That is, we should write, instead of 1 by 3 to the power of n u of n, you should write 1 by 3 to the power of n u of minus n minus 1, right? That is the minus of 1 by 3 to the power of n, sorry, 1 by 2 to, 1 to the power of n u of minus n minus 1, and this becomes 1 by 3 to the power of n minus of u of minus n minus 1, right? It becomes something like that. Here, since it was minus, is that minus, or here you should multiply with the minus, it becomes minus minus into minus minus becomes the plus, right? For the anti-causal sequence, the answer is here, sorry, it is minus, not minus 1 by 2, it is plus 1 by 2, plus 1 by 2, 1 by 3 to the power of n u of minus n minus 1, minus 1 by 2, 1 to the power of n, nothing but 1 itself, u of minus n minus 1. Here it is not multiplied with minus, please correct this one, right? This one is corrected, this becomes the plus, this becomes the plus, please concentrate. Similarly, we have one more condition, ROC. If it lies between 1 by 3 and 1, what happens? If it lies between 1 by 3 and 1, ROC is between the 1 by 3 and 1, right? For 1 by 3 it is exterior, and for 1 it is interior, right? For full 1 it becomes the what is that, anti-causal sequence. For 1 by 3 it is causal sequence. Hence you can write both sided sequence. For 1 by 3 it is 1 by 3 to the power of, that is answer, everything is same. The value of a and b, whatever you found out, everything is same. Only thing is the answer that differs, that is, what is that, minus 1 by 2, 1 by 3 to the power of n u of n, minus 1 by 2, 1 to the power of n, that is 1 itself, u of minus n minus 1, right? And this is the thing, you need to concentrate on the standard form what we have, that is the right-sided sequence, left-sided sequence, right? And one more is a double-ended sequence, right? All those things you need to concentrate. Based on the value of ROC, you need to judge where the ROC is located. Based on that, you need to apply the formula. Okay, please do the homework. Find the inverse Z transform of x of z is equal to z into z square minus 4z plus 5 divided by z minus 3 into z minus 1 into z minus 2 for the different ROC conditions, right? When z is located between 2 and 3, and when z is greater than 3, and when z is less than 1. Very simple problem, please try it.